we're going to look at another example of a chi-squared goodness of fit test. This one has to do with the color distribution of M&Ms. So according to the manufacturer of the M&M candy, the color distribution for plain chocolate M&Ms is 13% brown, 13% red, 14% yellow, 24% blue, 20% orange, and 16% green. Do the M&Ms in our sample, which is listed over on the right, suggest that the color distribution is different than that? So what we're being asked to do is do the M&Ms match the listed distribution? Okay, and that listed distribution are these percentages that are provided to us in the context of the word problem. Our hypotheses, so our null hypothesis is that the M&Ms have this distribution. Okay, and the alternative hypothesis is that the M&Ms do not have this distribution, or at least not close enough. Our assumptions and conditions. So we're checking to make sure we have some sort of random sample. And then for our expected ones, so these are our observed values. So for our expected values, we want to make sure that none of them are less than 1. So expected counts are all 1 plus. And then expected counts, I'm going to write this as at least 80% of them are 5 plus. All right, so rather than working this all out on a calculator, I'm going to go ahead and do that in Excel so we can speed this process up a little bit. So let me switch over for you. All right, so let's take a look at what I have on this spreadsheet here. So in this first column, in the A column, I have the percentages that the company claims are how the colors are distributed. I've listed those categories in the B column, and then I put our observed counts in the C column. So to get our expected ones, we need to multiply N times P. So N is our total, which is 300. And then our P's, our proportions, our percentages are listed along the side here. So for the expected for the brown, I'll do equals, and I'm going to click on that 13%. And then I'm going to say times 300 because that 300 isn't going to change. That's our N, so I'll just straight type that on there. And then once I have one formula down, I can copy and paste for all the rest of the categories. So I have all of my expected values there. And if I'm looking at those, none of the counts are less than 1, so I can check that criteria off. And the expected counts, none of these are even less than 5, so I can check that one off as well. And then the problem didn't state that this is a simple random sample, but that is fair to assume. So we're going to go ahead and just put a star and put fair to assume. Okay, and the reason that that's fair to assume is that really you could consider the industrial process in those machines as randomly putting those M&Ms in the bags. And so I think that's a reasonably fair assumption to make here. Since we've met all this criteria, the name of the thing we're doing, or our process, is a chi-squared goodness of fit. And we need to get our test statistic here. So to do that, we'll do that observed minus the expected squared over expected. So I'm just going to keep working in Excel here. So I'll do equals and open a parentheses. Now click on the observed minus, and then click on the expected. Close my parentheses, up caret, square it, and then divide by the expected again. So I'll click on that D2. So it looks like I have that all correct, so I'll hit equals. And then I'm just going to copy and paste that for the rest of the categories. And then remember, to get our test statistic, we just need to add all of those up. So I'll do equals the sum of all of those guys that we just calculated. So I get 9.22 for my test statistic. So I will write that guy down. And then let's get our p-value, and we can switch back to our paper. So we do have those two ways of getting the p-value. We have equals the chi-squared.dist.rt. You can always get a p-value from the distribution command. And it asks us for our test statistics, so I'll click there. And then my degrees of freedom. So there are 1, 2, 3, 4, 5, 6 categories. So 6 minus 1 is 5. So I have 5 degrees of freedom. So I get 0.1, or I can do this with the chi-squared test command. So that is the CHISQ.test. And then it wants the observed values first. And I'll put a comma and put the expected values. We should get the exact same number here. So there we go. So our p-value is 0.1. And then let's switch back to our paper so we can finish this up. All right, so you can see I added those things as I was talking in the video. So I marked the random sample as fair to assume and checked off the counts. Put down our chi-squared goodness of fit is the name of our test. And that 9.22 and a p-value of 0.1. And then I'm just going to use the standard alpha here, okay, which is 5%. So in this case, my p-value is bigger than my alpha. So I do not reject the null hypothesis, which means that with a p-value of 0.1 at the 5% significance level, we do not have sufficient evidence the M&Ms differ from the stated color distribution. All right, so there is our chi-squared goodness of fit test.